I've got something else to show you this time. For one thing, I finished all of these comparators. As you can see, I've got I've got the bit 1, bit for 2, bit for 4, and bit for 8, and then I've got all of the the collation things that just collect all the data from these and give me an output. And I haven't got this one here done. However, I've got something to show you this time. I can just straighten that out. Now watch this. You know the nixie dots that I showed you last time? Or I think I might have, but I can't remember. These I'm going to use to represent, for the data out of these relays, I'm going to display it on these little tube dots thing. So yeah, I'll show you this working. I've just got a switch down here. And there you go. You might see the thing strobing a little bit. It's not doing that to my eye, but it's just because I haven't got a filter capacitor. Sorry, not a filter capacitor, a smoothing capacitor, to get rid of all of the noise. Well, not the noise, it's the ripple from the AC line, because it's only... It's rectified, but it's not smoothed. That's an interesting value. That should be 0.5. No idea. 1 minute. I've got a adjustment potentiometer here to control the voltage. So, and I need to make it so that that number there is 5 milliamps, which is the rated current for this dot. So there you go, full brightness. I can't do this through the camera. Actually, so I'll go with it. It's quite dangerous, so I'm sorry if you can't see. But it does work. I've got my... it's very close to the high voltage line, so I'm trying to look through the camera and it's not doing well. So there you go, it does work. I don't want to get too close to it. As you can see here, I've got this bulb that I got out of the microwave dismantle. I'm using that as a current regulator. So it means if I ever short out these transformers, this light will just light up rather than the whatever I'm using blows up. It just absorbs that extra, the power, and it's much more likely that this will turn on, and the resistance of it will increase, and because of the heat, and then it'll stop too much going to the whatever I'm trying to blow up. So, yeah, little safety device. It's, well, not very safe. I've just got crocodile leads attached to it, but it's better than nothing. Yeah, I've got this doing. I'm going to build that one now. It's actually quite late at night at the moment, so wait till tomorrow. If you're wondering what the tape is on them all, it's actually just to hold them together. They're some of them are quite flimsy. If I can show you underneath, don't know if you can see it. It's only held together by one wire between the two. If I was to do it better, or more efficiently, I'd just have all of. I'd have that one, and that one in one thing, and that one, and that one in one thing. But to sacrifice that for modularity, which is far more important in case I want to add more to it. Because all of this is just for 4-bit, but if I ever wanted it to be, 8-bit, I can just, chain more on, build more, chain more on, add a few more of these. I don't need to change that one, and then just have more inputs, and, it works fine. I can't actually show you. I'd better turn that off in case something blows up. 2 seconds. This potentiometer gets hot because it's not rated for it. It's effectively shorting out the transformer through it, so I can use it as a potential divider, so that I can get the voltage to adjust the voltage for that. But it's not rated for it, so it gets hot. I need a something more like 47 k ohm. 470 k ohm if I'm really going for it, so that I can still have that, because it's not drawing much current. It's a few milliamps. It's really not gonna affect it. It's not gonna heat that up as much as shorting out the transformers through it. So I think it's worth it. But I haven't got one. This is just a 10k at the moment. It's all I had in my box. I've got a few, but they're all quite low values, 470 and 100 ohm, those sort of things. And yeah. What else did I do? Oh yeah, I don't know if I showed you in the last video. Actually, it wasn't even built then. I put my shelves back up again, so I've got some shelves. Sorry about the light. I've got some shelves. They're pretty neat. Just to put bits and bobs on. Because as you can see, this table is overflowing. There's more space than I had last time, and I still haven't got enough space. Obviously, a rack of tea mugs. You can never have enough tea. And all my tools are overflowing over there too. So yeah, I haven't really got anything else to show you. Oh, actually, I might as well show you this. I drew up a diagram. Ignore that. So, doing that, I did have these diagrams here, which are done in Sharpie, and they weren't actually very neat, because I don't know if you can see it, but the Sharpies bleed through the paper, which isn't very nice. But I drew it up in pencil, which is much neater, and it doesn't bleed. So these are just all the building instructions. Sorry about the glare on the wallets, but just to make sure I don't drop flux on it and ruin the paper. So, yeah, so that's all the building instructions, in case I ever forget. This was the previous magnitude comparator, but I wasn't checking for the previous order bits for the magnitude output. And there is a bud covered in flux. This is a primary example. That's a used bud with flux on it in the middle of my book. So I'm glad I've got these wallets in here. So yeah, and these are the ones that really aren't very neat. These are the ones I just did freehand without a ruler. So yeah, there you go. I haven't really got anything else to show you until I finish that off and start on my next one. I think I mentioned I got my relay memory working, so it means that I can store data. I have tested it, but I had to take it apart to build this, because this is what I've got a plan of things to build. I've got the adder, which does subtraction too. I've got the magnitude comparator. I've got the memory to build, which is the next thing. Then I've got to do instruction decoder. Then, well, I don't know what else I had. I can't remember how far I got with it. And I also need to build a clock thing. I haven't got the capacitor I was going to use. I'm using a relay and a capacitor which oscillates at a particular frequency. Depending on the capacitance of the capacitor, you can adjust the frequency that it oscillates, and you can work it out depending on the current draw of the relay. And I can't remember how much it used. I think it was, I don't know, 500 milliwatts power consumption, but it's more important with the the current draw of it, because the voltage stays the same. Yeah. What else do I have to talk about? I think that's it. I'll see you next time. Yeah. Goodbye, everyone.